This is lesson 47 for Algebra 1/2. Today we're going to evaluate exponential expressions and radicals. So let's start with a couple examples. Let's go ahead and make some space for more than one example here. So the first example I have is m squared. So we know that 2 is the exponent, so this is m, some variable taken to the second power. And we don't know what it is. But if we did know what m was, we could evaluate it. So I'm going to evaluate it, which means I'm going to calculate the value if I know that m is equal to 12. So in order to evaluate it, all I would have to do is plug in 12 or replace the m with 12 and take 12 to the second power. So m squared becomes 12 squared. What is 12 to the second power? 12 to the second power is just 12 times 12, which is 144. So that's a pretty simple example. So this is an exponential expression because it has an exponent. Let's do also a radical expression. So a radical expression contains a radical in it. So we're going to evaluate the expression, the nth root of 64. So the radical is this symbol, and this symbol means that we're taking a root. A root is an opposite of an exponent. So the nth root of 64, I don't know what that is unless I know what n is. So I'm going to evaluate this if I know if n equals 3. So if n equals 3, I just replace the n with a 3. So I can say this is the third root of 64. So what this is really asking me is what number times itself 3 times to make 64? Well, if I don't know, I can try some small numbers. I know that 1 to the third power is just 1. And I know that 2 to the third power is 2 times 2 times 2. So that would be 8. And I try 3 to the third power, and that would be 3 times 3 times 3, which is 9 times 3, which is 27. I could try 4 to the third power, which is 4 times 4 times 4, 16 times 4. And that just happens to be 64. So using trial and error here, I just listed out some third powers, some cubic powers, and I found out that 4 to the third power is 64. And that means that the third root of 64 must be 4. Let's do a couple more examples. You can try these ones on your own. The first one, let's evaluate 4 to the x power if x is equal to 4. So go ahead and try that one. So checking the answer on this one, if I replace the x with 4, I get 4 to the fourth power, which is 4 times 4 times 4 times 4. I can group together these 4s and make it 16 times 16, which is 256. Now for the next example, we're going to evaluate the third root of n, if n equals 27. So try that one on your own too. So checking our answer for the second one, if we replace the n is 27, we're trying to find the third root of 27. And we've already talked about 3's before. We know 3 to the third power is 3 times 3 times 3, which is 27. And we know that that means that the third root of 27 must be 3. So let's do 2 more quick examples. The first one would be to find the value of x to the third if x equals 6. So try that on your own. So checking the answer on this example, we have x to the third if x equals 6. So we just take 6 and replace it with the x. We have 6 to the third power, which is 6 times 6 times 6. I can group that into 36 times 6, which I've calculated to equal 216. All right, and now for the last example. The last example I've got here is evaluate 0.5 to the y power if y equals 4. So be careful with this one. You're going to take a decimal number and take it to the 4th power. So go ahead and try that one on your own. And so checking the answer to the last example, if I have 0.5 to the y power and the y power is 4, I'm really taking 0.5 to the 4th power. So 0.5 times 0.5 times 0.5 times 0.5, which I get 0.25 times 0.25. Now, you have to be careful with this because you're multiplying decimal numbers and you're using long multiplication. Since you're not using a calculator, you're doing it the old-fashioned way like this, right? So we have 0.25 times 0.25, and we just have to remember at the end we get 625, but we have 1, 2, 3, 4 places before these decimals. So I actually move the decimal 1, 2, 3, 4, which means I have to add a 0. So it's 0.0625 for my final answer for this one.